Hello guys, welcome to today's class. In today's class, we'll be discussing this very interesting exercise. Differentiate the following. A, y equal to x to the power of x. B, y equal to x to the power of x to the power of x. And if this is your first time seeing my videos, do well to follow through to the end of the class. And if you enjoyed this video, do well to subscribe to the channel so you get notifications when I upload new videos. Now let's solve these problems. Now let's pay attention to the solution to this first exercise. We have y equal to x to the power of x. How do we differentiate this function? Now it is important to note that when you have x raised to a given power, which is a variable and not a number, we have to take logarithm on both sides. And in calculus, we are interested in log of natural numbers, which is ln. So we're going to take ln on both sides whenever we have an index to be a variable. Okay, so we take ln on both sides. Taking ln on both sides, we have ln y equal to ln x to the power of x. And there is a rule in logarithm that when you have an index of this form, it multiplies the logarithm. I mean, this will be ln y equal to x ln x. Okay, now at this point, we can now differentiate both sides. If we differentiate ln y, we have 1 over y. But because this is an implicit function, implicit differentiation, because we are differentiating y, we return dy dx. Remember, whenever you're differentiating a function, you're differentiating y, which is the dependent variable, you return dy dx. So we return dy dx. And on the right hand side, we have a product rule. We have x and we have ln x multiplied. So we take product rule. And what's our product rule? We hold x, differentiate ln x, plus hold ln x, differentiate x. Okay, so we hold x, differential of ln x is 1 upon x, plus then hold ln x, differentiate x, you have 1. Please know that this means multiplication. Okay, so we've differentiated the right hand side and we have to simplify from this point. On the left hand side, we have 1 over y dy dx. And on the right hand side, x divided by x is 1. So this simplifies to 1. Plus ln x times 1 is ln x. Okay. And this will give us, if we multiply through by y, thus making dy dx subject, we'll have dy dx equal to y into 1 plus ln x. And thus, our dy dx would be, remember our y is x to the power of x. So replace the value of y here, x to the power of x into 1 plus ln x. And this is our dy dx. And that's how we differentiate this function, y equal to x to the power of x. Its derivative is x to the power x into 1 plus ln x. Now let's differentiate the second exercise. We have y equal to x to the power of x to the power of x. Now it is important to pay attention to how this function is written. If we have x to the power of x to the power of x, some persons might confuse this to be x to the power of x or to the power of x. And this is wrong. This, if you write it this way, this means that you are having something of this form, x. Now this power will multiply this power and you have x squared. This is what this means. But this means x to the power of x to the power of x. So this is raised to this power. Why this is raised to all of this? That is what this function means. Don't confuse it with this particular setup. Okay, so how do we now differentiate this setup? This particular setup here, x to the power of x to the power of x. Okay, just like we did in the last example, last exercise, we are going to take logarithm on both sides because the index here is a variable. So we take logarithm, we take the ln on both sides, log of natural numbers. So taking the ln on both sides, we'll have ln y equal to ln x to the power of x to the power of x. And because these two are together, remember this is x to the power of x to the power of x, we apply the rule of logarithm where this goes as a coefficient or multiplies this logarithm here. So we have ln y equal to x to the power of x ln x. Okay, so from this point now we can differentiate both sides. So we differentiate ln y, we have 1 upon y dy dx. And on the right hand side, we have a product rule to apply here because we have x to the power of x multiplying ln x. And what's our product rule? Like we did earlier, we hold the first term, differentiate the second one, and then hold the second one, differentiate the first one. So if we hold x to the power of x and we differentiate ln x, we have 1 upon x. Plus, we now hold ln x and differentiate x to the power of x. In the previous exercise, we did the differential of x to the power of x. And we got that its differential is x to the power of x into 1 plus ln x. That's the derivative of x to the power of x from the exercise A we did earlier. So we have this set up here. And then next step we simplify through. So from this we have 1 upon y dy dx equal to, if we simplify this, x to the power of x times 1 is x to the power of x all over x. Plus this to this, I want to keep x to the power of x out first. So this is x to the power of x ln x into 1 plus ln x. Please note that the setup is immaterial. I can keep this out and then multiply here. I can also decide to keep it out. Both ways are correct. So from this step, we can now try to make dy dx subject by multiplying through by y. So we will have dy dx equal to y into x to the power of x over x plus x to the power of x ln x into 1 plus ln x. And so our dy dx, remember our y is x to the power of x to the power of x. So this will be x to the power of x to the power of x into x raised to power x over x plus x to power x ln x into 1 plus ln x. This is our dy dx. We can go further to try to simplify, where we can have x to power x to power x into x to power x, applying our law of indices here. This can go up and this is -1 plus x to power x ln x into 1 plus ln x. You can go on to simplify further, but at this point, we've got our dy dx. And any simplification you make here is still correct to be our dy dx. And that's how we differentiate this very interesting function here, y equal to x to the power of x to the power of x.